everybody, this is Rudra Pradhan here. Welcome to BMD lecture series. Today we will continue with the prescriptive analytics and that to coverage on sensitivity analysis. We have already discussed couple of problems in this particular unit, that is the prescriptive analytics, and that too we have dealt with lots of business problems where we have objective functions, maybe maximization type or minimization type subject to certain constants, maybe constants are in a kind of normal setup. For instance, with respect to maximization problems, the constants must be in the less than type, and in the case of minimization problems the constants are greater than type. And also we have solved some of the problems where corresponding to a particular objective function, whether maximization type or minimization type, the constants are both less than type and greater than type, and also the kind of equality type. Again, we have also solved some of the problems where some of the special issues we have addressed, like infeasibility of particular problems, the kind of unbounded solutions, and the kind of multiple solution, degeneracy problems, redundant constraints. So, that means we have dealt with so many business business problems with different kind of nature and different kind of features. So, that means typically in the prescriptive analytic structures we must have objective functions subject to constants and condition, and then we have solved the idea behind this particular process is to find out the optimum values of the decision variables through which we can address the business problem more effectively, more efficiently, and come with a kind of management decision as per the particular business requirement or the kind of management requirement. In this particular unit, we like to address some of the issues where we can address this kind of problems in a more attractive way. For instance, the business is altogether very dynamic game, and we will find every moment there is this kind of change. So, the topic that is the sensitivity analysis will be very helpful in this context. So, that means with respect to a particular problem, so we have objective functions, maybe maximization type or minimization type subject to constants which may be in a normal kind of natures or the kind of abnormality like less than type or greater than type, and the kind of equality. But obviously with respect to a particular situations at the particular time frames. So, we have a kind of setup, or we have a kind of problem structure through which we can get the optimum solutions, and that too the values of the decision variable through which you can address the business problem as per the particular requirement. But now getting the optimum solutions or the values of the decision problem to address this problem, you may have a kind of structure that some change may happen in futures, that may be with respect to the coefficients of the objective function, the coefficients of the constants may be in the less than type, may be in the greater than type, or we may have more number of constants or less number of constants. So, these are the following changes may happen. So, that means typically we have already gone through predictive analytics, where we have a kind of information basket where we have a data corresponding to a kind of problems and some kind of theory and the kind of structure corresponding to theory, structure, and objectives, the requirements. We like to connect all these data and come with a kind of models that will forecast or predict the future kind of business requirement. So, now once the model is ready, then we will find out some of the constants and conditions, the kind of uncertainty. Then again in this kind of situation or in this kind of scenarios. So, we like to again have the optimum values of the decision variable subject to all these changes like the kind of as per the particular business requirement. So, that means what I like to address here in the predictive kind of analytics. We have already dealt with some of the problems like having data, having the kind of requirement, having the kind of conditionality. We may get some kind of model that will address the future requirement, and then we have lots of flexibility. So, changing the data structures, increasing this data size or decreasing the data size, increase the number of variables or decrease the number of variables, increase more number of equation or change the kind of functional form. So, several ways we can address the kind of problem, then we come with a kind of solution which is actually more efficient and more effective. And exactly the similar kind of framework we can have in the case of prescriptive analytic structures. In this case, with a given problems with that means with respect to a particular objective, constant and conditions, we may have optimum solution, that is the values of the decision variable, which can address the problem as per the requirement. But again we like to have some kind of what I can say different kind of options or alternatives subject to change of these kind of requirements. So, that means we are in this kind of prescriptive analytic structures. So, the given situation is the kind of specification of the objective function and constant, that too the parameters, that the coefficients of the objective function and constants are more or less constant. Then we like to solve the kind of model that is what the linear programming model which we have discussed, and then we come with a kind of optimum solution. Now, there may be high chance that the coefficients of the objective function may change as per the future business requirement or the kind of change of the business environment or with respect to competitive kind of scenario. So, that means technically we are addressing a particular business problems, but that business problems may be connected with a similar kind of business problems, may be connected with different competitors or different sectoral problems or different kind of specification of the business. So, that means technically there may be high chance that the coefficients of the objective functions or the coefficient of the constants may change. Again there may be high chance that some of the additional constants may be coming into the picture, and some of the constants we may drop if there is no necessity in the kind of future kind of requirement or the kind of business requirement. So, that means the item which I like to address here today is like this, that we have a given problems where we have objective function, constants and conditions, and then we like to predict the kind of structure where if any change happen with respect to objective functions or coefficients of the constants, may be left hand side, may be right hand side, and the change of the numbers of constants, then what will happen to the optimality, that is the values of the decision variables. So, there is a high chance that if the problem is very perfect and very consistent, any change you can do with coefficients of the objective function or the coefficient of the constant, that too in the left hand side or in the right hand side, and then change of the constants may not drastically or may not change at all the values of the decision variable or the kind of optimality. So, in fact, in reality, and if any change happen with respect to objective functions or the coefficients of the constants or change of the number of constants, there may be chance that the optimality structure will change. That means, the values of the decision variable may change, or else the value of the objective functions may not change, but the structure of the optimality may change. For instance, in the first instance we may have a kind of 3 variables problems where a particular variable say x 1 is not coming, that means the value of x 1 is coming 0, where the value of x 2 and the value of x 3 may be something positive. And now any change with respect to constants and the kind of coefficients of the either objective function or constants or both. So, the the optimality structure will remain constant. That means, still x 1 is not coming into the picture, x 2 is still there and x x 2 is still there, but the values of the decision variable will change. If the values of the decision variable will change and the typical structure is constant, then by default the value of the objective function will change. So, that means, what I like to say, with respect to dynamics of business, there can be anything. So, obviously, it is a kind of challenge for us, and now with the help of LP, linear programming and the kind of softwares and the kind of programming. So, we like to predict the possible changes as for the future requirement or the kind of business requirement. Then with a present conditions, we try to extract the optimality and the optimum structure. Then with respect to prediction of future requirement, then we like to predict again what should be the optimality of futures with respect to the change of the particular business setups, that is with respect to change of the coefficients of the objective function, the coefficient of the constraints and the kind of number of constraints corresponding to a particular problem. Sometimes we can put the condition of the decision variable. For instance, the typical optimality will change if we put like let us say the values of the decision variable may be integer types, then the problem will be can be solved with a different kind of structure. For instance, we first try for optimal solution, and if it is not coming to the integer type kind of solution, then again we have to restructure the problem and continue with the kind of operation till we get the optimality or the values of the decision variable, which will exactly follow the kind of integer type as per the particular requirement. And these are the various dynamics, and that is the particular requirement as per the given kind of situation or the dynamics of business or the change of the business environment. So, now this kind of means this topic will address all the issues and the kind of challenges, and then give you the kind of exposure that if what should be the kind of solution for the existing problems, and then what will be the kind of solution with respect to different change situations. Now, we have a two different kind of understanding. First understanding is that, so what should be the possible changes with respect to the given problems, that too if you are changing the coefficients of the objective function or coefficient of the constants or the number of constants. So, definitely there is a kind of proper planning or the kind of strategy through which you can change the particular structure or the kind of requirement. Then after that we will look for the optimality or the optimum solution as per the particular requirement. So, that means we have addressed lots of problems, and now we like to solve some of these issues, and then we like to check how these are all coming in the kind of real life scenario or the kind of business scenario. So, I start with a simple problem, and the way we have solved in the last couple of lectures. And now, I like to first connect with a particular problem and use the softwares, that is the solver package, and let you know how these program the particular problem can be quickly get the optimum solution through the solver package. Then I will connect with the sensitivity structure, and then give you the kind of understanding and the kind of clue how you have to address the optimal problem or LP problems with respect to changing business environment or the change of business dynamics. Okay. So, let us see here. So, how is the kind of structure. So, let us say consider this particular problem. So, we have already solved this problem, and now we like to solve this problem through the kind of solvers. That means, technically this is a solver problems, and that too it is a maximization problems with respect to two variables and with respect to three constraints. And then we are trying to say solve the problems to look for the values of the decision variable and in this context we have already solved this problem by graphical structure, by simplex structure, and again we take this problem and then we like to or we like to know the kind of solution through solver. So, for that, so we can go to the Excel solvers. So, here the kind of structure is like this, and in fact we like to start with a new problem, and for that so let me take you to the new Excel sheet, and then we start with a simple problem which we have already here. So, this is what the problem, and then we like to solve through the kind of solver package. So, what will you do? So, we like to start with a kind of structure like this. Let us see here so how we can actually solve this type of problem in a kind of simple framework. So, we start with the structure like this. In the first structures we will put dv, that is called as decision variables, and then we will have a like objective function, that is profit type, and again so we have the kind of constraints. We have the kind of constraints, and so these are the typical structures. So, we have a our requirement is the values of the decision variable subject to availability of profit functions, that is the objective functions, and the kind constraints, and then the kind of conditions. So, assuming that it is a kind of positive values of the decision variables kind of requirement. So, this problem is with respect to two variable case, that is the bivariate case. So, as a result, so we will put x 1 here and we will put here x 2. So, this is how the kind of indication, and then we first start with the coefficients of the objective function. Since there are two variables, the objective function structure will be maximizing z equal to C 1 x 1, C 2 x 2. So, C 1 is already given here, that is actually 60, and then for x 2. So, this is actually 50. So, that means the simple understanding of this problem is so we are hoping at least 60 USD will be for x 1s and 50 USD for x 2, and then we like to know what is the exact profit. Then for that we look the x 1 quantity and x 2 quantity, and for that we need to have a first the kind of exact problems, then we look for the kind of solutions. So, in these problems we have two constraints, three constants: assembly constants, inspection constant, and storage constant, like what we have here already, assembly constants, inspection constant, and storage constant. So, now that means we go to again Excel sheet and then put the constants. So, again all the constants are with respect to both x 1 and x 2. So, obviously, the first constant, that the assembly constant is with respect to 4 x 1 plus 10 x 2 less than equal to 100 hours. So, obviously, so for x 1, so it will be 4, and then for x 2 it is 10, and then this is first constant, and then the limit maximum limit is 100 here. So, this is 100. So, this is what we can put here, the kind of limit limit, that is the resource availability, and then the okay. So, we can put here limit, then this is what we can put the kind of signal okay. So, this is the case signal means it is the kind of indication about the kind of constants. That means the constants may be less than type, may be greater than type, may be equality type. So, this will give you the kind of signal, and the limit is here actually 100. So, that is the availability, the minimum availability or the kind of maximum availability, depending upon the kind of signal structure. If it is less than type, then this is the this limit will give you that that is the maximum limit through which you can reallocate the research or allocate the research to get the optimum solution. If you will put greater than, by default the indication is that it is the minimum requirement of this particular research allocations. Then come to the second constant, that is the inspection constants, and for that 2 units of x 1s and then 1 unit of x 2, and against the constant is less than type. The constant is again less than type, and the limit is 22, and this is inspection constant. Then the third constant is a 3x storage constant, that is 3 x 1 and 3 x 2. Obviously, 3 for x 1s and again 3 for x 2. So, this is like input matrix arrangement, and obviously, this constant is also less than type. So, again you put here the kind of less than type of situation. Okay. And then so the limit is here again 39, and so you put here 39. Okay. So, now the issue the entry is ready to operate. So, the first end operation is like this, we put here, then we like to define the objective function, which is nothing but actually C 1 x 1 plus C 2 x 2, and then we are looking for the values of the decision variables. So, obviously, so the x 1 value which we can have here is like this. So, multiplied by profit coefficients, then plus against x 2 values x 2 value, and then multiply corresponding coefficient, and against we can actually block these ones, and for that we can put to the kind of restrictions, and okay, this is for B 3, this is for B 3. Okay. And again, so we can block this one for C 3. So, we can block this one for C 3, and okay, this is again blocking C 3. So, now this is ready to operate. Okay. So, now just this is for profit function, and you can scroll down for rest of the constraints. So, now this is how the now on the operation is ready to operate. So, then you go to the data analysis package, like we have already solved some of the problems, inferential analytics problems and the predictive analytics problems, where we have used the data analysis package now. So, just data analysis package in the Excel software. So, we have a solver package, just you click here, then you will find the screen will appear like this, and here. So, we have actually 3 different structures, that is the objective function structures and the kind of changing variable cells, and then the constants box. So, first and requirement is setting the objective functions, that is what actually this value. Okay. So, first of all we go for reset. Okay. Okay, close this one. Okay. So, now okay, so now we can go to the data solver. Okay. All right. So, this is what the first and choice is the kind of objective functions, and that is actually we are putting the indication about to the D4. Then again you go to the second option, that is the changing variable options, that is with respect to x 1 and x 2. Again, so you click here, and then we set up the constant sites, and in the constant sites we in the box we will go add-ons one after another. So, this is the first constraints, and the corresponding constant indication is the less than type. Then the constant limit is actually less than type less than equal to 100. So, we can indicate less than 100. Then this is the entry of the first constants, then we can add on the second constant. For that again we go to this particular second constant 2 x 1 plus x 2. So, which is here against the signal is less than type, and the constant limit means research availability is this much. So, we can again freeze these ones, then again you we can go for add on third constants, that is actually 3x1 plus 3x2, and against the signal is here against less than type, and against the constant availability say that is B3. So, which is nothing but 39. Okay. So, now this is what ready. So, now we can put OK. So, now this is what the operations, and corresponding to this problem. So, we have objective functions, we have the kind of changing variable cells, that is with respect to both x1 and x2, and the input of 3 constants, and again we have lots of options here. So, if there are more constants, then we can add on continuously till you close this particular problem, and again there is a change option, we can change as per the particular requirement. That is how the sensitivity analysis will work there. And now with the given situation, we look for the kind of optimum solution. Now in the solving methods, we have here GRG nonlinear and simplex LP. So, now we are actually discussing the problem LP, and that too we have already discussed graphical structure and simplex structure, and now we are putting the simplex structure, and then we give the option of solve. So, now so this is how the solve options. Now, this is now operative. So, now it is ready for the solutions. So, now here there are 3 options: answer, sensitivity and limits, and then we are giving option to 3. Of course, the sensitivity part we will discuss after this particular solution. So, let us see how is the kind of solutions. Now, this is what the operation is ready now. So, initially these two are blank. So, now it has the entry. So, that means the entry is 9 for x1s and 4 for x2. So, that means now the optimum solution is like that, the value of x1, the decision variable x1 is 9, and the values of x2, that is the decision variable 2 is 4, and as a result, so your profit function will be 60 into 9 and 50 into 4, that will give you 740, and then these are the kind of constant kind of optimality. So, here if you compare with research kind of use, this is what actually the optimality problem, where the major kind of structure is how to allocate the resource effectively, so that the objective function will reach at the highest level. So, that means typically it is a kind of research allocation process, and there are 3 constants here, and the maximum availability of resources are there. So, now we are optimizing and changing the structure as per the particular requirement. So, that means for the first constant the maximum limit is 100, the second constant the maximum limit is 22, and third constant the maximum limit is 39. So, now after the solutions, that means we have already gone through simplex procedure, and simplex procedure idea is that we have the idea of moving from first step to last step. That means it is a typically the iterative process, moving from a particular corner point to optimum corner points. Every stage the value of the objective function will be in a kind of increasing signal. That means technically in this kind of situations, so we like to check where is the kind of optimality. So, in the solvers it will not give you the stepwise kind of indications. So, that means technically what are the possible corner points, but it will give you the exactly the final solutions, that is the optimal solution. But if you go manually, then you will start with first optimum solution, then first improve basic feasible solution, second improve basic feasible solution, then finally final optimum solutions. So, now in the solver package ultimately it will give you the last step of the particular process, where the value of the objective function is the optimum, and that too at the highest levels. So, now after getting the optimum solution, we like to check the kind of constants. So far as the first constant is there, so the maximum limit is 100, but the utilization is 76, second constant 22, and the availability is also 22, third constant we have reached 39 and maximum availability also 39. So, that means we have discussed the concept called as binding and non binding. So, the second and third constants are binding, and the first constant is not binding. So, that means still some resources are left even after the optimality. So, that means we have a kind of resource pool. So, there is a high chance that all the resources may not be fully utilized while having the kind of optimum solutions, but whatever way we will change and structure it. So, ultimately we will have optimum value corresponding to these kind of availability only. So, now in this kind of situations we have already highlighted the particular requirement. So, now on the basis of solutions, so the maximum profit which you have reached here is 740, and that too the values of the x 1 is 9 and value of x 2 is 4, and as a result the particular business firm reach at profit of 740. So, that means the values of the decision variables for x 1 is 9 and for x 2 4, and that too value of the objective function z equal to 740, and it satisfy all the constants as per the particular signals, that is the less than type. So, now this is the original solution, and that to first and optimum solution, and of course, we have reached the optimum solution with respect to touching all these corner points, and out of all these corner points we have targeted the kind of optimal one. Now, coming to the sensitivity part. So, now the process will start from here. So, now with respect to whatever optimum solution we have reached, so we like to change some kind of requirement, means some kind of structuring that may be with respect to objective function, that may be with respect to constant. So, for instance, here the constants inputs are 4, 2, 3, 10, 1, 3, and that too for x 2 and x 1 respectively, and then the coefficient of objective function 60 and 50, and the limit of the constants are 100, 22, 39. That means if we apply sensitivity analysis, so that means the change can happen with respect to either 60 or 50, that is the with respect to objective function, and the coefficient of the constant. So, that means the input can change actually, instead of 4 you can put 5, or you may put 3, 2 like this. So, any change you can put here, and again in the right hand side you can put any change. Then again after after allowing the particular change, again you allow the solver to run the model, and then again we check the optimum solutions. There is a possibility that the optimum solution after the change will remain constant as per the original one, or there may be actually change with respect to the original one. So, whatever may be the situation, so it is a kind of again iterative process, and that too with respect to all changes. Then finally, we come with a kind of solutions which can be very effective as per the particular requirement. So, with this actually we have addressed the particular business problem, and that too. So, in these problems corresponding to these objective functions, we have already discussed the solution in the graphical methods, and again the summary of the solution is like this. So, here the kind of structure is 740, that is the highest optimum z value subject to other corner points, that to in the first end point A 0, second 660, then 700, then 500. So, that means if you go by simplex methods, so it will start with first the value z equal to 0, then z equal to 500, then z equal to 660, then 700, then finally 740. So, that means simplex method is a very fantastic structure. It will arrange systematically starting with the lowest value of the z to the highest value of z. So, where we have to freeze the optimum solutions. So, now solver will ultimately give you the final step, and that to declare the optimum values of the decision variable and the optimum value of z's, and that to the kind of original kind of scenario. So, that means with respect to objective function and the kind of conditions with respect to all these iterations, finally, we reach the optimum solution. Now, after getting the optimum solutions, then we look for the change scenario. So, that is what the sensitivity analysis altogether. So, now we look for the sensitivity structure, and so far as the sensitivity structure is concerned, we have the following objectives. So, the objectives and the kind of understanding is so we like to highlight how sensitivity analysis can be used to a decision makers or decision making process, explain why it can be useful for a decision maker to extend the analysis of a linear programming problem beyond determination of the optimum solution, and again explain how to analyze and interpret the impact of the change in the value of the objective function coefficient. Again, we like to address how to analyze and interpret the impact of change in the right hand side value of the constant. Again, we like to interpret what a dual is and formulate the dual of a problem, and again interpret dual problem related to dual solution to primer solutions, and explaining economic interpretation of the primal problems and the dual problem, and again examining the kind of situations if adding another variable to a problem, whether the optimum value will change or optimum solution will change, against whether adding one particular constants whether the kind of optimality will remain constant or there is a kind of change. So, that means we have a different kind of options. Now, that is how the prescriptive analytics is a very interesting. We have the kind of original structure, and that to first and we need to find out the optimum solution corresponding to the original problem, provided the problem must be very consistent as per the particular requirement or the kind of business setup. And then we like to first predict the change situations with respect to objective function, constants, and the kind of condition, and again we go we go on the stepwise process, or we follow the kind of iterative process till we get again the another optimum solution corresponding to the change scenario. And again we like to compare the optimum solution with respect to the original structure, and again optimum solution with respect to changing structures. Then we like to address how is the kind of business structures or the kind of business problem, and then we come with a kind of management decision as per the particular requirement. So, that means it will give you lots of extra flexibility to address the problem more effectively, and then you can take the management decision more efficiently as per the need and the kind of requirement against. So, with this we will stop here, and we will continue this particular discussion in the next class. Thank you very much. Have a nice day.